Hello everyone, welcome to this video. In this video, apart from learning how to solve this question, you will be also learning how we can simplify such kind of calculations when we are talking about dihedral groups. So let's have a look at our question. They are saying that if we are given some dihedral group Dn, right? So we are talking about the symmetries of the polygonal having n sides, correct? So if we are talking about such a polygon here, and if this R represents reflection, which where each reflection is obtained by dividing 360 by the number of sides, right? And if we represent F by any reflection, then we need to write these calculations, these expressions in the form, either in the form of some power of R or some power of R composed with F, right? This is what we want as our answer to these statements, correct? So let's proceed by solving each of them. Before solving, you should know certain results. We first of all consider that this represents our reflection and F represent our reflection. Sorry, R 360 by n represents rotation. Here it should be rotation, correct? And here F represents reflection in Dn. Then we have several results, you know, R F R is equals to F. This result we already know. F R F is equals to R inverse. From where do we obtain these results? Remember, we have studied about this result in the previous video where we have proved this thing for any dihedral group, and moreover we have also studied about this group, this result in the previous video, right? So we are using these results here. And then moreover, you know, any reflection when it is composed together with the reflection gives you the identity, because once you are doing the same thing again, reflecting it two times, then you will get back the same thing, which is the identity operation, identity rotation, correct? So you can write this thing as also F as its own inverse, right? This thing also you know. And moreover, we also have this result that R subscript n superscript m could be written as R subscript nm, right? So this is also very powerful result which we shall be using here. You can verify this result geometrically. You know about the group D3 or you know about the group D4. You can easily verify it for these by looking at all the rotations. Is it always true? Okay, that is another exercise. As of now, let's proceed towards our question here. So moving forward onto the first part here, we have D4 as our dihedral group. So n is equals to 4 here, right? If n is 4, then our rotation becomes 360 by 4 is 90. So we have R90 as our smallest rotation. Now we are given this expression. So here, instead of writing R, you can write R90 and R90 here. Now we can use this to write down R90 raised to power minus 2 as R minus 180 and R90 raised to power 5 as R450. There is no issue. Then you know, once you rotate any object by 180 degree, and if you rotate it by minus 180 degree, you would have the same orientation, correct? So therefore this R minus 180 is equals to R 180. So we can replace it like this. Why we have done so, you'll see that in a moment. And moreover, you can write this R 450. Now you know, by in 360 degree we complete one rotation. So after 360 degree, all they would be matching with each other. So 0 would correspond to 360. Then 90 would corresponds to 360 plus 90, correct? Similarly, 180 would corresponds to 360 plus 180. So similarly, we can write this 450. 450 is what? It is 360 plus 90. So you could write this as R90 here. So this is same as writing R90. So we have written R90 instead of this. Now we can use the formula onto these three expressions. The formula used here is FRF, that is equals to R inverse. So you can write the inverse of this, which is R180 inverse, and you have R90 as such. Now what you can do, you can instead of writing R minus 180, you can write R180 here, right? And moreover, because we can use this expression, so therefore we would have R, instead of writing R 180, you can write R as 180 as 2 into 90. So you could write it as 90 and 2 here. So that is what we have done here. So you see, what is this? This is the cube of R90. And what is your R90? It is the smallest rotation. So you can write it as R cube. So we are successful in writing this expression as some power of R in this particular case. Correct? Now let's take our second example in D5. In D5, we have n as equal to 5. So our smallest such rotation would be 360 by 5, which is 72. So we are given this expression. We can write in place of R 72. Correct? Once you have done that, now what you can do, you can solve up this power. So it would become minus 216. You can multiply minus 3 with 72. It will become minus 216 using this expression. F is as such. You can break this power 4 into power 1 and power 3, right? So into these two parts. F is as such. This is as such, right? Now why I have done so? Because you see 3 into 72 is again 216. So we have the same terms like here. So you can we can use this term here to write down this as F, correct? And then we can copy down the other terms here, like this term, like this. Now again, this was power how much? This was power 1. You can write power 1 as minus 1 plus 2, correct? There is no issue. You can write it like this. So therefore, we have written 72 raised to power 1 as 72 raised to power minus 1 and R 72 raised to power 2, right? Why? Because here we have R 72 raised to power minus 2, which we wanted to get rid of. So therefore, we here also want R 72 raised to power 2, so that we can apply the result onto this expression. So once you apply this result, it would give you just F, right? So this is F, and R 72 raised to power minus 1 is as such. Now again you can apply the the result here, which is F R inverse F is equals to R. So we have R 72 here, so this is equals to R here, and this is our second part, right? For the third part, we are in D6, so our n is 6, so our smallest rotation becomes R60. So we wanted to simplify this expression. So instead of R, we can write R60, right? So what we can do, we can first of all use simplify this expression. You can see F, you can see R, you can see F. So using this expression here, you have R minus 2 would become R square, correct? So you see, now we can add up the powers because the bases are same. So we have this quantity. Now here we wanted to write the expressions in the form of some power of R or some power of R multiplied composed with F. These are the two required form which is required to us by the question, right? So therefore you can write, because here we have R60 raised to power 7, so here also we want R60, so we can write R0 here, and because R0 you can write it like this, the inverse of the same quantity, so we have written the power 7 here. So we can combine these terms here, it would become F. So what we wanted the positive power of this, so we can again apply this result. Minus 7 into 60 would become minus 420, correct? So this is R minus 420F, and you can write minus 420 as minus 2 times of 360 plus 300, so that it would give you just 300. So minus 420 is equivalent to R300 into F, and you can write 300 as, because we wanted to write it in terms of 60, so we can write it as 5 into 60. So you can write it as R60 raised to power 5 using this result, and then R60 is nothing but your R, so your answer comes out to be R raised to power 5 composed with F. So you can solve such kind of calculations very easily once you are used to it. You can, I insist you to solve these calculations by yourself. If you know these results, you just have to apply them one by one in order to get the answer, correct? So that is it for this video. Thank you for watching.